So we're going to continue our discussion of complex numbers, but we're going to talk about operations with complex numbers: addition, subtraction, multiplication, and division. All right, so let's start with addition. Addition is very similar to adding radicals, where you're just going to combine like terms. So 2 plus 5i plus 1 minus 7i, you simply combine your like terms, the 2 and the 1, the 5i plus the negative 7i to get 3 minus 2i. Subtraction is very similar. The only thing that is different is you have to be a little cautious about distributing the negative sign. So this would be 5 minus 6 for a negative 1, 4i minus a minus 3i, so it'll be 4i plus 3i, which would be 7i. So minus 1 plus 7i. When you're multiplying, you're going to do pretty much the same operations as you would do for any numbers. You would distribute the 4, and so you would get 8 plus 16i, remembering that you want to keep it in the a plus bi form, which it is already. On this next one here, you're going to distribute your I, so you'll have 3i minus 5i squared. But remember that I squared is negative 1, so this would be 3i plus 5, and then you need to switch it around to have it in the proper form, 5 plus 3i. On number 5, you'll distribute the negative 3i, so you will get negative 6i minus 18i squared. Again, the I squared is a negative 1, so it'll be negative 18 times negative 1, which would be a positive 18. And then you have to make sure you have it in the correct form, so 18 minus 6i. Okay, you have 2 plus 3i times 5 plus 2i. There's no operation in between the two parentheses, so this is multiplication. Always look for that to make sure there isn't a plus or a minus sign in between. But this here you're going to FOIL or double distribute, whatever word you learned, where you are going to say 5 times 2 for the 10, 2 times 2i for the 4i, 3i times 5 for 15i, and 3i plus 2i for 6i squared. Combine your like terms, change your I squared to negative 1, and you'll get 4 plus 19i. All right, this next one here is a little bit interesting. 5 plus 3i and 5 minus 3i. Those are the same numbers, just different signs in the middle. Those are actually called complex conjugates. When you multiply those together, the middle terms actually end up dropping out, and you'll have 25 minus 9i squared. The I squared is a negative 1, so it'll be 25 plus 9 for a 34. And again, these are called complex conjugates. They are parentheses that have the same numbers. So division. If I have 10i over 8i, your kind of probably reaction would be to just simply cancel those i's, and that would be absolutely correct, and then just simplify the fraction, 5/4. I's are going to be very, very similar to radicals, where you cannot have an I in the denominator. So just like a radical, you would multiply the numerator and the denominator by I in order to get rid of that in the denominator. So your numerator would become 4i. Your denominator is negative 3i squared, but I squared is negative 1. Make sure when you write it, you put 4/3 and then the I kind of next to it, because you always have to write it as the real part and then the imaginary part. This one here, you can just simplify your i's. So I squared divided by I will just give you I in the numerator, and negative 8 divided by 2 is negative 4. All right, when you have something like this, just like in multiplication, I cannot actually simplify these because they are imaginary numbers. So the first thing I have to do is pull out the negatives as i's. So I'll have 2i times the square root of 5, I square root of 15. Now I can go ahead and simplify those i's by canceling them out, and then simplify the square root of 5 over the square root of 15 to the square root of 3. So now I'll have 2 divided by the square root of 3, but I'll have to rationalize this by multiplying by the square root of 3 over the square root of 3. All right, 5 and 6 look like they are very similar problems, but they are two very different problems. When I have two parentheses both underneath the same radical, now it's okay for me to multiply these two numbers together. So I can write this one as the square root of 16, which would simplify to 4. But on number 6, when they are written as two separate radicals, I can no longer multiply those together because remember that multiplication rule is only for real numbers. So now I have to pull the i's out first. So I'll have I square root of 2 times I square root of 8. Now when I multiply them together, I'm going to have I squared square root of 16, which will simplify down to negative 4. So if you look at number 5, when they're both underneath the radical, I have a positive 4, but when they are separate radicals, I actually end up with a negative 4. Complex conjugates, just ignore the scribble on the bottom, I don't know why that's there. Complex conjugates are two complex numbers whose real parts are the same and whose imaginary parts are opposite, like 3 plus 0i and 3 minus 0i, 5 plus 3i, 5 minus 3i. All right, so let's go ahead and take a look at number 7. Now there is an I in the denominator, so I need to go ahead and get rid of that or rationalize that. The way that I can do that is to multiply by its complex conjugate. So anytime you have addition or subtraction in the denominator, you cannot just multiply by I over I. You have to multiply by the complex conjugate. So I'll multiply numerator and denominator by 2 minus I. So when I multiply that all out, I'll get 6 minus 3i, 4 minus I squared. But I squared is negative 1, so it becomes 4 plus 1. And now I've got 5 in the denominator, and you can see I no longer have i's. And also, once again, make sure you write your answer in the a plus bi form. Again, on number 8, you're going to multiply by the complex conjugate, 4 plus I, 4 plus I. You multiply it all out. You're going to combine all of your like terms, change your I squared to a negative 1. And you have 10 plus 11i over 17, but you cannot leave your answer like this. It needs to be in the a plus bi form. So you'll write it as 10 over 17 plus 11 over 17i. When you are solving equations, you have x squared equals negative 9. You're going to square root both sides, so you're going to get plus or minus the square root of negative 9. But remember, we already discovered that the square root of negative 9 is 3i, so your answer is plus or minus 3i. Very similar with the square root of negative 5. You're going to have plus or minus the I times the square root of 5. The reason why the I is in front this time is because if you are handwriting this, as you can see as I've kind of scribbled below, sometimes it's very difficult to tell whether the I is underneath the radical or outside of the radical. So to avoid that confusion, we take the I and put it in front of the radical. 3x squared minus 8 is 7x squared. Again, just like in Algebra 1, you're going to start by combining all of your like terms. So 4x squared minus 8, divide by 4, and take the square root of both sides, not forgetting your plus or minus, and then pulling out that negative as an I. All right, here you're going to divide by negative 2, but when you do that, you see you have a negative underneath your radical, so you can immediately pull that out as an I, and I'm going to rationalize this at the same time. So I pull the negative out as an I, but I have a square root of 2 in the bottom, so I have to multiply the numerator and the denominator by the square root of 2 to rationalize that. Here it's not, you could actually have your answer in either case in this one, but it's because you have a fraction, it's a little easier to see that the I is not actually underneath the radical. All right, so once again, when you are solving by square rooting, you want to get the term that is squared alone, so I would divide by 3 first. Now I would square root both sides. So this negative 16 will become a plus or minus 4i, and now you can just add 4 to the other side. So to continue our talk about imaginary numbers, we're going to talk about graphing. So ordered pairs in the form of A, B, representing the real parts of a complex number, can be graphed on a complex plane. So the x-axis is going to be where you're going to put all of your real numbers. So this becomes your real number line. And the y-axis is your imaginary number line. So that x is real, y is imaginary. So if you're going to graph point A, 6 plus 4i, the real part is 6 and the imaginary part is 4i. So on the real number line, you'll go over 6, 1, 2, 3, 4, 5, 6, and then you will go up 4 on the imaginary line. My dot misses just a little bit, but you can see that would be point A. If you're going to be graphing point B, it would be negative 3 on the real number line and 5 up on the imaginary point B. Point C is only real, so you can think of this as 4 plus 0i, so point C would just be on the real number line. And D is only imaginary, there is no real part, so it's going to just be on the imaginary line. It would be here, negative 6. Now let's talk about how to find the absolute value of a complex number. To do that, you have to think about, well, what is the absolute value? And the absolute value is defined as the distance of a number from 0. If you can keep that in mind, I think it will help you remember how to do this. So here we have our graph, real and imaginaries, and I want to find out what is the absolute value of 6 plus 4i. Well, let's first graph this point. So over 6 on the real number line, up 4. But if you remember that by definition the absolute value is the distance from 0, then this line here is the distance that we want to find. If we can find the length of this segment, then we know what the absolute value of 6 plus 4i is. Well, we know that the horizontal distance is 6, and we know the vertical distance is 4. So we can just use our Pythagorean theorem in order to figure this out. So c squared, which is our hypotenuse, which is what we're trying to figure out, is 6 squared plus 4 squared. If you do all of this math, you'll find out that it is the square root of 52. And if you take a look at how this works, you're just going to take the real part and square it, and take the imaginary part and square it. Of course, square root of 52 can be simplified to 2 times the square root of 13. So the formula is a plus bi. You're just going to take the square root of the real part plus the real part of the imaginary number, and then take the square root of that. Remembering that you have to square them and add them together before you can take the square root. Go ahead and try this one and see if you can get the right answer. So again, if you plot this, this will be negative 3, 5i. That length is the distance that you're trying to find. So it'll be 9, which is negative 3 squared, plus 25, which is 5 squared. Add the numbers together to get 34. So the absolute value of negative 3 plus 5i is the square root of 34. If you wanted to find the absolute value of negative 6i, well, right here, this is your distance here is negative 6. So that simply will just be 6, because it will be the square root of 0 plus 36, which is just 6. All right, that's it for imaginary numbers. If you have any questions, let me know.